The reign of the F-22 Raptor, once the undisputed king of the skies, is coming to an end. This legendary fighter dominated the battlefield with unmatched speed and stealth, but something far more powerful and revolutionary is on the horizon: the X59. This supersonic, near-silent aircraft, designed by NASA, is poised to usher in a new era of faster-than-sound travel without the thunderous sonic boom, sparking a wave of excitement and speculation among aviation enthusiasts worldwide. But can the X59 truly surpass the Raptor's legacy? What makes this sleek, futuristic craft more formidable than the fifth-generation F-22, once hailed as invincible? The answer lies in its cutting-edge technology and groundbreaking design. Join us as we dive into the advanced capabilities of the X59, a marvel engineered to replace the Raptor and redefine the future of aviation as we know it. The supersonic jet. Development of the X59 began back in February 2016 when Lockheed Martin secured a contract to design this groundbreaking aircraft. The goal? To make supersonic flight not only faster but quieter, reducing the disruptive noise that led to a halt in the production of previous supersonic jets. By 2017, Lockheed was testing a small model of the plane in a wind tunnel, refining its design with the hopes of having it in the sky by 2020. Though delays pushed the timeline back, the X59 remained a top priority, with NASA even receiving bids from multiple companies, only to ultimately stick with Lockheed for this mission. By late 2021, NASA and Lockheed Martin were working hand in hand to make this dream a reality. Wind tunnel tests at NASA Langley provided vital data on the aircraft's stability and control at various speeds, as well as airflow dynamics, all of which helped shape the final design. With a sleek 99, 7-foot-long frame and a wingspan of 29.5 feet, the X59 is built for speed, cruising at Mach 1.42, well over the speed of sound, at altitudes of 55,000 feet. But what makes the X59 truly unique is its use of innovative noise-reducing technologies. The jet's engine, a General Electric F414, is positioned on top of the plane to minimize ground noise. The long, slender design and strategically placed canards are engineered to reduce the sonic boom to a mere 75 decibels, about as quiet as a car door shutting. Compare that to the ear-splitting boom of the Concorde, and it's clear why the X59 is a game-changer. One of the more fascinating features of the X59 is its lack of a traditional cockpit view. Due to its elongated nose, pilots can't see directly ahead. So the aircraft uses a cutting-edge advanced vision system, AVS, with a 4K camera and enhanced flight visuals to give pilots a crystal-clear forward view. Collins Aerospace has provided state-of-the-art avionics, including a system that visualizes the sonic boom's impact and infrared sensors for precision landings. NASA's game changer. After rigorous safety checks, NASA is set to test the X59 Quest over U.S. cities to gauge its noise levels and public reaction. This will help regulators decide if it's safe to allow supersonic flights over land. Beginning November 5, 2018, NASA planned to conduct tests for 2 weeks, generating up to 8 loud sounds a day across various locations. With 20 noise sensors and 400 residents involved, the goal was to gather precise feedback. Participants were even paid $25 a week to track the noise, with results influencing new rules on sonic booms expected by a 2027 meeting, with potential changes in supersonic travel regulations by 2028. In the meantime, NASA and Lockheed Martin have made significant progress. By late 2021, the X59 was fitted with the powerful General Electric F414 GE100 engine, which, at 13 feet long, produces an impressive 22,000 pounds of thrust. On August 4, 2023, Lockheed Martin proudly showcased the X59 rolling out of its hangar, and by January 12, 2024, the aircraft was officially revealed to the public. Despite its technological advancements, one critical question remains. Does the X59 truly address the sonic boom problem that has hindered supersonic flight? The X59's design aims to tackle the sonic boom head-on. Unlike traditional supersonic aircraft that produce a single thunderous shockwave, the X59's special surface shapes and unique engine placement, mounted on top of the plane, are intended to spread out the shock waves. NASA anticipates that this innovative approach will reduce the noise to around 75 decibels, comparable to distant thunder or a car door closing, which is far less startling than previous supersonic aircraft. The X59 is set to fly at speeds of up to Mach 1.4, significantly faster than sound, but designed to avoid the intense noise of earlier supersonic models. Initial test flights will occur at Lockheed Martin's Skunk Works, followed by crucial tests at NASA's Armstrong Flight Research Center in California. The real game changer will be the series of test flights over 6 diverse neighborhoods in the U.S., scheduled for later in 2024. These flights will be monitored to ensure noise levels are kept to a minimum and public reactions are thoroughly assessed. This approach is a deliberate move to avoid the mistakes of 1964, when the Federal Aviation Administration's supersonic jet tests over Oklahoma City caused significant public outrage. With up to 20% of residents disturbed and some demanding compensation, NASA aims to ensure the X59 doesn't repeat history. By first testing in restricted areas and then gradually over neighborhoods, they hope to keep noise levels manageable and acceptable. After these tests, NASA will consult with local residents and gather feedback on the 75 decibel boom, aiming to make supersonic flight over populated areas a reality. If successful, new regulations could pave the way for supersonic travel routes like New York to Los Angeles, potentially halving flight times and revolutionizing air travel. Cold War's stealth superiority. The F-22 Raptor saga began in the 1980s, a response to the growing threat posed by Russia and China as they ramped up their fighter aircraft programs. With the Cold War intensifying, the U.S. Air Force needed a game changer. Enter the Raptor. Its advanced stealth technology and twin-thrust vectoring engines promised unmatched agility and invisibility. Designed to outmaneuver any adversary in dogfights, the F-22 quickly became the gold standard for air dominance. By the 1990s, as the Cold War simmered down and the nuclear arms race gave way to the pursuit of air superiority, the F-22 emerged as a beacon of technological prowess. Its introduction in 2005 marked the pinnacle of stealth and firepower. Yet, as the Soviet Union collapsed and new conflicts took center stage, the Raptor's role became less about combat and more about deterrence. The aircraft's sheer presence was enough to keep potential adversaries in check, even though it never engaged in air-to-air combat during its operational years. The Raptor's design is a marvel of engineering, balancing stealth with aerodynamic performance. Its radar-absorbent materials, hidden hinges, and specialized flat-thrust vectoring nozzles make it nearly invisible to radar and infrared detection. Its shape, featuring sleek, curved surfaces and carefully aligned edges, further reduces its radar cross-section to that of a small marble. This meticulous design allows the Raptor to operate almost undetected, ensuring it can strike before an enemy even knows it's there. Equipped with 2 powerful Pratt & Whitney F-119 engines, the F-22 can reach speeds of Mach 2 and operate at altitudes of up to 50,000 feet. Its advanced flight control systems and digital cockpit offer unparalleled situational awareness and agility. The cockpit features a cutting-edge HUD and multiple LCD panels, all streamlined for efficient data processing and control. This high-tech setup ensures that pilots have all the information they need to maintain air superiority, even under the most demanding conditions. Despite its impressive capabilities, the Raptor has seen limited use in modern conflicts, largely due to shifts in military focus and the changing nature of warfare. Its role as a strategic deterrent has proven invaluable, but its high operational costs and the emergence of new technologies have led to debates about its future. The F-22's development halted in the early 2000s, making way for the more versatile and cost-effective F-35 Joint Strike Fighter. As we look to the future, the X59 Quest promises to usher in a new era of supersonic flight, potentially overshadowing the F-22. This aircraft aims to tackle the sonic boom issue with innovative design solutions, potentially transforming how we think about supersonic travel. But does the X59 have what it takes to dethrone the Raptor? The answer lies in its ability to combine cutting-edge technology with practical performance, setting a new benchmark for future aircraft. The end of an era. Is the F-22 Raptor, the most advanced fighter jet of its era, on the verge of being outclassed by the newest technological marvels? Despite its cutting-edge design and unparalleled stealth, is the Raptor facing its twilight, or will it continue to dominate the skies? Buckle up as we dive into the features that make the F-22 a formidable force and reveal why its reign might soon face serious challenges. The F-22 Raptor, a symbol of air dominance, carries its arsenal in a sleek and efficient design. With a main bay capable of holding up to 6 AIM-120C air-to-air missiles and 1 000-pound GPS-guided bombs, and 2 side bays accommodating AIM-9 Sidewinder missiles, it's built for versatility. A 20 mm rotary cannon in the right-wing root adds to its formidable armament. When stealth is not a priority, the Raptor can carry up to 5,000 pounds of additional weaponry on each of its 4 underwing points, making it a versatile predator in the sky. Despite its incredible capabilities, the F-22's advanced technology has led to some unique challenges. The jet's stealth coating, initially failing in rain and moisture, highlighted the complexities of maintaining such a sophisticated aircraft. Stealth maintenance, consuming nearly 1/3 of all upkeep efforts, is a time-intensive process, with major maintenance performed at Hill AFB's Ogden Air Logistics Complex. Over time, maintenance efficiency has improved, but the costs remain high, with each flight hour now costing $5,916. The introduction of new low-drag fuel tanks, designed to be more aerodynamic and stealthy, aims to enhance the Raptor's range and performance. These upgrades, along with improvements to stealth and sensors, reflect the U.S. Air Force's commitment to keeping the F-22 at the cutting edge of air superiority. Despite budgetary constraints and the evolution of rival technologies like China's J-20 fighter, the F-22's capabilities are being continually refined to ensure its relevance until the next generation aircraft arrives. Now, you might be wondering about the X59 Quest and its role in this equation. Despite its groundbreaking technology and potential to revolutionize supersonic travel, the X59 is designed primarily for civilian use, not as a military replacement for the F-22. The real contender for the Raptor's crown is the Next Generation Air Dominance (NGAD) program, which promises to usher in a new era of fighter technology. As we look ahead, the F-22 Raptor's legacy is solidified by its unmatched performance and ongoing upgrades. But with the NGAD on the horizon and civilian innovations like the X59 paving the way for future advancements, the world of military aviation is poised for dramatic shifts. For more insights into the cutting-edge world of aviation and defense technology, click the link on your screen to watch another one of our videos. Don't forget to like, subscribe, and hit that notification bell so you never miss out on the latest updates. See you in the next video.